Hello everyone, and I'm AliaBazeel. Welcome to my project that is Smart Waste Classification using machine learning. In this project, I developed a deep learning model to automatically classify waste into three categories, that is metal, paper and plastic. This supports the sustainable recycling practices. Manual waste segregation is slow, inconsistent, and error prone. Misclassified waste can contaminate recyclables, harming the environment and increasing the cost. To address this, I used machine learning, specifically convolutional neural networks, to automate waste classification. Using transfer learning with MobileNet V2, the model achieves reliable performance even with a moderate dataset. The primary dataset is Trashify image dataset from Kaggle, which contains images of metal, paper and plastic. Images were resized to 224 into 224 pixel. I can show you that over here. After importing all the required libraries, I did the parameter. Over there, I gave the pixel. I resized it, normalized and augmented with rotation, shifts, shear zoom, brightness adjustment and horizontal flips. You can see it over here. A small custom dataset was also created for instant testing. That is this dataset, AliaB test image. Only few images were used for making this dataset. Augmentation helps the model generalize better and distinguish visually similar waste items. Now talking about the data processing and splitting. It was Kera's image data generator was used to normalize and augment images. You can see I have imported it before. The dataset was split into 80% training and 20% validation using the validation_split parameter, ensuring robust training and evaluation on unseen images. Coming to the model construction with fine-tuning, I built the model using MobileNet V2 pre-trained on ImageNet. The last 20 layers were unfrozen for fine-tuning, while earlier layers retained pre-trained weights. I added global average pooling 2D. You can see that. A dense layer with 128 neurons and ReLU activation, a dropout layer and a final dense layer with softmax activation for the 3-class classification. The model was compiled with Adam Optimizer at the learning rate of 0.0001. Coming to the model training, the model was trained for 12 epochs using augmented data. Training and validation accuracies were monitored to prevent overfitting. Validation accuracy reached approximately 77%. You can see. Showing strong performance for the dataset size, fine-tuning and augmentation help the model distinguish between visually similar items. When it comes to the model evaluation, performance was evaluated using accuracy and loss curves, that is this plot. A confusion matrix was also given. After that, I gave the classification report. Most misclassifications occurred between thin plastics and crumpled paper. Overall, the model demonstrated robust performance for automated waste classification with high precision, recall and F1 scores. also given a Gradio interactive demo for the users. Over here, I created a Gradio interface for interactivity. Users can upload an image and receive real-time predictions. The top 3 predicted classes are displayed along with the confidence distribution bar chart. Example images for the custom dataset, that was the dataset that I made, are included for instant testing. Then I have also used some emojis, that is to classify the metal, paper and plastic. That is just to ensure the interface make visually engaging for the users. I'll just run my Gradio and show you how it works. So here is the link. After clicking the link, I can drop the image from here. That was from the dataset that I made. So it shows, yes, it's a plastic, and the prediction confidence distribution bar chart is also here. Now I'll go for another image. Yes, it's showing it's a metal. And one more image. Yes, even this showed as it's a paper. Now if we need, we can even take an image from Google. So I'll go for one of the images. I drag drop the image, so I got it as a metal. So yes, that's how my Gradio works. To conclude with the assessment, I must say the model successfully classifies waste into metal, paper and plastic. Transfer learning with MobileNet V2 and data augmentation allowed reliable predictions with limited data. The Gradio interface provides a user-friendly and interpretable platform. Future work could expand datasets, integrate real-time camera system. We had a camera system, but then it was not showing perfectly, it was not working perfectly. So in the future, I can make it work properly. Then deployed lightweight models on mobile devices, demonstrating ML's potential in sustainable waste management. So that's all for this video. Thank you everyone for watching the video.